Hi all, welcome to the next topic of Unit 1, Timing and Control. Let's see the contents. Introduction of what is Timing and Control Unit. Design of a control unit, which can be done using two methods, hardwired control unit and microprogrammed control unit. So coming to the introduction. In the first topic of Unit 1, we have already discussed about the block diagram of a digital computer, where the CPU, the central processing unit of a computer, contains three parts. It is divided into three parts: the arithmetic logic unit, control unit, and memory unit. Coming to the arithmetic logic unit, as we know, it is used to perform arithmetical and logical operations on the data which is stored in your memory unit of a computer. And the main use of a memory unit in a computer is for the storage of your instructions and data. So they can be either stored permanently or temporarily, depending upon the type of memory that is used. Next, the other part of the CPU is a control unit. So what is a control unit? So the main function of the control unit is to generate the relevant timing and control signals to all the operations in the computer. Whenever any operation has to be done in a computer system, that is the role of a control unit to generate the relevant signals, control signals. So based on the control signals only, the operations will be performed in the computer, whatever type of operation it might be. So it controls the flow of data between the processor and the main memory as well as the input output devices. So the control unit must communicate with both the arithmetic logic unit and main memory, and not only main memory but also input out all the peripheral devices which are connected in the computer. So it instructs the arithmetic logic unit what logic or arithmetic operations that has to be performed. And the control unit coordinates the activities of other two units as well as peripherals, auxiliary storage devices which are linked to the computer. So it should be in coordination with all the parts that are present in the computer system for the smooth execution of instructions in a computer. So coming to the design of a control unit, how the control unit was internally designed. So it can be designed in two ways. It can generate the control signals using any one of the two organisms or two mechanisms. One is a hardwired control unit and other is a microprogrammed control unit. So let's see what are they. So you can design your control unit using a hardwired control unit or by using a microprogrammed control unit. So in case of a hardware control unit, you can implement a control unit by means of a logic circuits, such as through the hardware components like gates, flip-flops, decoders. You can have them internally in your hardware and implement the control unit. So that's why we call it as a hardwired control unit. But this type of organization is very complicated if we have to implement a very large size control unit in our computer system. And in this organization, if the design has to be modified or changed, in that case you require the changes in the wiring among multiple components that are connected in the system. So the modification is not so easy. It is very difficult to modify once it has been designed. So coming to the advantages and disadvantages of a hardwired control unit, the hardware control unit is fast because the control signals are generated by combinational circuits. So it works very fast. Coming to the disadvantages, the design part is very complex. It is more complex in design and modifications. As I told you, the modifications is not very easy. It is very difficult to perform modification because we require the rearrangement of all the wires present in the hardware circuit. And it is difficult, it is also difficult to correct the mistakes in the original design. If you want to add some new feature in the existing design, it is very difficult to do so. It makes the things complex. So if you see here, this is the control unit of a basic computer. So it consists of two decoders, two decoders, a sequence counter, and a control logic gate. So if you see here, whatever the instruction which is fetched from the memory unit, it is placed into a register called instruction register. And this is a 16-bit register. The components of the instruction register contains the I bit, the opcode, and bits, address bits from 0 to 11. So the opcode in bits 12 to 14, they are given as an input to a 3 by 8 decoder. Okay, and the decoder generates 8 outputs D0 to D7 that are given as an input to a control logic gate. And the opcode, the addressing mode, opcode at bit 15, it's transferred to a flip-flop which is designated by the symbol I. This is an I flip-flop. And the operation code from 0 to 11, address bits from 0 to 11, they are applied to the control logic gates. So the sequence counter, it takes the increment, clear, and clock pulses as input, clock as input, and it is given as input to a 4 by 16 decoder. So this sequence counter can count in the numbers or binary from T0 to T15. It generates, since this is a 4 by 16 decoder, it takes 4-bit sequence counter. Uh, it gives an output of timing signals from T0 to T15. So this is the hardware organization of this implementation of hardwired control unit. Next, we have other type of control unit. It can be designed using a microprogrammed control unit. So what do you mean by a microprogrammed control unit? So by means of a program, you're going to design the control unit. So that's why we call it as a microprogram. Microprogram, by means of a microprogram, the control unit is being implemented. So a microprogram control unit is implemented using a programming approach. So here a sequence of micro instructions are carried out by executing a program consists of micro instructions. So you are going to write a micro program which consists of micro instructions, and these micro instructions are stored in the control memory of the control unit. There is a memory available in the control unit. We call it a control memory. In that memory, this program resides. And the execution of the micro instructions is responsible for generating the control signals. So whenever the micro program, the instructions which are present in the micro program are being executed, they are responsible for generating the control signals. So what does a micro instruction contains? It contains one or more micro operations that needs to be executed, as well as it also contains the address of the next micro instruction. So microprogram contains set of micro instructions, where each micro instructions contain the operation that has to be executed, as well as the address of the next micro instruction that has to be executed. So coming to micro operations, the operations which are performed on the data that is inside the registers, we call them as a micro operations. So the micro instruction contains micro operations specified. And microprogram is nothing but it is a concept for generating the control signals using programs. So we call them as a microprograms. Next, coming to the advantages and disadvantages of microprogrammed control unit. So this is less complex when you compare it with a hardware control unit. The design of a microprogrammed control unit is very less complex in design. And the microprogram control unit is more flexible because you can easily perform modifications or corrections or enhancements that can be easily done because you are writing, it is implemented by means of a program. So that is one advantage. And the new or modified instruction set of a CPU can be easily implemented by simply rewriting and modifying the contents of the control memory. So when your instruction set is modified, then you can easily do it because uh, you can easily replace them by rewriting the or modifying the contents of the memory unit of the control unit. And finally, the fault can be easily diagnosed by means of some diagnostic tools. You can easily diagnose if any fault in your control unit design by that is one more advantage. Next, coming to the disadvantages of microprogrammed control unit. It is slow when in terms of execution of an instructions. This microprogram control unit is slow compared with a hardwired control unit. And the microprogram unit is also expensive. When you compare it with the hardwired, it is a bit expensive in design than a hardwired control unit. And the design duration, it takes a more time compared to a hardwired control unit. So these are the disadvantages of microprogrammed control unit. Let's see the design of a microprogrammed control unit. So here we have next address generator, control address register, control memory, which is your ROM, and control data register. So the control memory address register, it specifies the address of the micro instruction that needs to be executed. And the control memory is assumed to be ROM, read-only memory, within which all the control information is permanently stored here. And the control data register, it holds the micro instruction fetched from the memory. So control address register contains the address of the micro instruction. So in the ROM, the particular instruction will be fetched and it is placed into a register called control data register. Once it is placed in the control data register, the micro instruction will be executed. And while the micro instructions are being executed, the next address is computed in the next address generator circuit and then transferred into the control address register to read the next micro instructions. So once this is being executed, the control address generator generates the address of the next instruction and places that particular address in the control address register. So this is how. So the next address generator is often referred as a microprogram sequencer. We also call it as a microprogram sequencer because it determines the address sequence that is read from the control memory. Okay. So this is the design of a microprogrammed control unit. So let's see the differences between the hardwired control unit and microprogrammed control unit. In terms of implementation, the hardware control unit consists of fixed set of logic gates and circuits to implement. In case of microprogram, you are writing a microcode or a microprogram which is stored in the memory of a control unit. And the flexibility, in terms of flexibility, hardware control unit is less flexible and it is difficult to modify the design. In terms of microprogram, it is more flexible and it is easy to modify. And coming to a complexity of design, hardware control unit is simple and simple design and it is easy to implement. But in case of microprogram, the design is complex and it is very difficult to implement. In terms of speed, the hardware control unit is fast when compared to a microprogram control unit which is slow in operation. And debugging and testing, it is difficult to debug and test in case of hardware, but here it is easy to debug and test by using some debugging tools. It is easy to be done. And in case of maintenance and upgradability, you cannot easily upgrade or easily maintain the hardware control unit. In case of microprogram, it is very easy to upgrade and maintain. In terms of size and cost, so the size of a hardware control unit is very small and the cost is also very less. But in case of microprogram, it is large in size, the size of your program, and the higher in the cost. So these are the differences between hardware control unit and microprogrammed control unit. So this is how the timing and control signals are generated by the control unit, and the hardware implementation, like what are the different organizations in which the control unit can be designed. Thank you.